couple more minutes, and I'll go through them. Here, I'm going to pass out the thing we're doing next, but don't do it yet. I'm just getting into it. Yeah, so you could find both separately and then add it together. That's weird.
Yeah.
Your exam is your chapter test. Or your exam slot on Thursday. You'll have a review on Wednesday for sure. Quite know yet what we're doing tomorrow. We're in this weird spot where we're not going to be able to finish all the probability. Which is fine. I'm just trying to figure out how far we get today and what we're going to do tomorrow. Whether it's review or some new stuff. But for sure you'll have a practice test Wednesday and then your test. You good to go over this? Alright. So, first of all, it says assume replacement for all. Why is that important? So you draw an M&M, record the color, green, red, whatever it is, you put it back. Why does that matter? It resets the probability, it keeps the probability the same, it makes sure they're independent, like one draw has nothing to do with the next draw. Those are all good answers. What's the probability to draw a green M&M? So you just add all these up. You know they all have to 1, right? So I think it's 0.15, is that right? So if I add up the other ones, I get 0.85. I have to 1, so it's going to be 0.1. Probability for 3 draws in a row, I get a non-red. So I draw, and then a draw, and then a draw. As long as your probabilities are independent, which these are because you replace, you just multiply them together. So the probability of getting a non-red is 0.7. That just happens 3 times, or you can just say, okay, that's 0.7 up there, that is 0.343. What's the probability to draw a red, and then a green, and then another green? So again, it's just these slots. So red is 0.3, green we found was 0.15, and then another green was 0.15. We multiply those. We got 0.00675. Good so far? Alright, 4 red in a row that are either red or brown. So I'm drawing 4. What's the probability that when I draw one it's either red or brown? We can add those up, right? So that's 0.5 probability that it's either red or brown. So this is where you might start getting sick of the slots. Just go, okay, never mind, that's 0.5 before. Either way, so what I want to see is 0.0625. How many add up? Good. 6 straight draws, I get an orange, or brown, or yellow. So I'm going to go orange is 0.2, plus brown is 0.2, plus yellow is 0.1. I'm not going to draw 6 slots because I'm lazy, so I'm going 0.5 to the 6th. That's 0.015625. Something like that. That's awesome. Very cool. I've given this worksheet out, I think the Friday thing really helped. I've given this worksheet out before. There's been like every single person was raising their hand, some questions nobody got right. So I think the Friday, like that slots thing, is that how you guys think about it? Is that helpful?
Yeah.
Very cool. Alright, 2 browns in a row or 2 reds in a row. So you can think about this like 2 separate things. Or you can put it in one equation, whichever you want. But I want a brown and then a brown. Or, and what does or mean when you're thinking about probability? It means add them up. A red and then a red. So you can kind of do it that way. So a brown and then a brown would be 0.2 times 0.2. Or are red that are red, and then technically we're supposed to subtract that ORA formula. What are we subtracting at the end? An overlap. Is there any overlap? Can I get 2 browns in a row and 2 reds in a row at the same time? There's no overlap to subtract. So this is 0.04, this is 0.09, so we have 0.1. That's tough. How many 0.13? Question on that? Does that make sense when how that went through? I forgot to say it's the rate. Because it's worded so weird. Like, I don't know what that means. It can be interpreted 2 different ways. So what's the probability I draw 2 in a row of the same color? So what's the probability I draw 2 browns in a row? 0.2 squared, right? What's the probability I draw 2 reds in a row? 0.3 squared. 0.1 squared. This is 0.15 squared. 0.2 squared. 0.05 squared. When you get all those numbers, what do you do with them? Add them all. And that comes out to 0.2. Does that make sense what I'm doing to get it? I can see some people writing on the answer, but if you just write the answer, that's useless too. We good? Okay. Alright, take out that sheet I just gave you. Let's start looking at that. So this is basically focused on this formula. We haven't really worked with that one yet. So maybe you want to write this at the top. Most of the problems we do in this on this one are going to have to do with that. And you've done this. You've just done it with Venn diagrams instead of with form. I'll kind of show you how you can use either for some of them, but you can't for all of them. So your general formula is the probability of A given B is the probability of both. Which, where would that be in the Venn diagram? That's like the overlap part in the middle, right? Divided by the probability of B, which is the thing we know is true. So if I look at number 1, I'm going to do it the Venn diagram way. Which is a little weird because you don't have all the information. But we can still do it. And then I'm going to show you how the formula matches up. So if I make the Venn diagram, this is stats, this is MCIS. 30% take both. So 0.3 goes in the middle. And then 50% take MCIS. So what percent is left over in the MCIS circle? 0.2, right? So answer the question right now. Like, don't use the formula, don't even look at the stuff I just put up there. But what's the probability that the student is in AP Stats if we know they're in the MCIS? 0.3 out of what? Out of 0.5, right? So you would say, okay, what's the probability they're in the MCIS, which is what? 0.5. And then in that 0.5, what's the probability they're in stats? It's 0.3. So you would get 0.3 over 0.5. If I use the formula, I would say, what's the probability they're in stats given that they're in the MCIS? That would be the probability of stats and MCIS divided by the probability of MCIS. So whatever is the given is what goes on the bottom. Well, if you start plugging in those numbers, what's the probability there in stats, MCIS, and MCIS? Is the 0.3, right? That's the overlap of the circle. And then what's the probability there in the MCIS? 0.5, and isn't that just the size of this circle, which is what we put right there? Then you can divide those out and get 0.6, but that's not the point really. It's the same thing. It's just doing it without the Venn diagram. You kind of skip it to a formula. The formula is a little better in some situations than that. Number 2, I forgot to tell you some information. So put 25% on both. But then again, let's go through both. So we'll do the diagram, do the formula, kind of see how they both go together. I'm going to do the formula first this time. So the probability that they own a car, if we know they own a bike. So I do the probability of C given B, car given bike. And that would be the probability of C and B divided by the probability of B. So again, the given one is always what goes in the bottom. What we know goes in the bottom. So just using the numbers, no diagram, what's the probability of car and bike? Now I told you 0.25. And what's the probability of bike? 0.7. So that should be your answer. It should be like 1/3, right? Well, if you look at making a Venn diagram, car, bike. You can do this either way you want. I'm just trying to show you that they're both the same. I think it'll help you understand it. 0.25 would be in the middle. 50% own a car. Well, 25% are in this part of the car circle. So what's left to go the other part of the car circle? 0.25. And then for the bike, 75% of people own a bike. 0.25 are already accounted for, so what's left to go here is 0.5, right? And then if you were just using the diagram, when I said, okay, find the probability that they own a car, if we know they own a bike, you would just start by going, okay, how many people own a bike? 0.75. Out of those 0.75, how many own a car? 0.25. So you end up with 0.25 over 0.7. You know what I'm saying? Like they're really the same thing. It's just a different way to get to it. But if you look at number 3, the Venn diagram sucks. So read through that one. So sometimes the formula is way easy. Because if you try to make the diagram, you kind of get stuck. I didn't even try it. I was just saying, you can try it. So if I go to make the diagram, I'm like, okay, studied, passed. The probability I studied and passed is 0.7. Great. But it doesn't tell me the probability that I studied. And it doesn't tell me the probability that I passed. So I get stuck. Like I can't just put a number there and I can't put a number there. So like, where do I go with the diagram? And this is where the formula is necessary. So if I look at the formula, the probability that I studied, probability to pass, if we know that you studied. The probability to pass, if we know that you studied. Let's just put the letters in first. What would go on top of the formula? Passed and studied. And what would go on the bottom? Part we know, the study, right? Well, this is what we're looking for. So it's a little bit backwards. So I gotta plug in the formula and work it the other way. And I know 2 of those 3 slides, it's just not the 2 that I'm used to doing. So what's the probability that I passed given that I studied? That's the point 8. What's the probability I passed and studied? That's the 0.7. And then you can just call it X. And that's what we're trying to find. So the diagram kind of falls apart a little bit, but this method will work. And then if you remember, there's this rule that says we can flip-flop those. So X is going to equal 0.7 over 0.8, which comes out to 0.87. So that's the toughest kind for most people because you have to, it's like you're working backwards and the diagram doesn't really help you. Unfortunately, they're kind of the most rare kind too, so they're not super common. Questions on 1, 2, or 3 there? Try 4 and 5. And I don't care if you do a diagram, I don't care if you do the formula. And I kind of recommend doing both. So you kind of see how they relate to each other. Neither of those are the backward tricky kind. More straightforward kind. I think what we'll do tomorrow is Frappies. We'll either do 2 or 3 Frappies. Practice tests. Practice multiple choice on Wednesday. How many got those 2? You good? Okay. Let's go back. I want to look at 6. Kind of together. So if I look at, raining today and wearing a blue shirt. So just start, right away, are those 2 related? I would, you could argue, you could be like, well, it's raining today, I'm sad, I like to wear blue when I'm sad. I mean, you could, make up some stupid thing, but, look at it the other way. If I wear a blue shirt, that would make it more likely to rain. No. So these should be what? Independent. And the 2 things are independent. When I tell you one of these pieces of information, does that change the probability of the other piece? It does. So keep that in mind as we're working through this. So the probability that it rains today, given that I wear a blue shirt. So what goes on top? Not the number, but like the formula. Rain and blue, right? What goes on the bottom? Rain or blue? Blue. However you know, what goes on the bottom. I don't know why I just thought of this. Did everybody see Knives Out? Have you guys? Really? Nobody's seen it?
No. No, wait, is it about the older couple?
There's older people. It's like a murder mystery.
I saw a trailer for like an older couple now.
Knives Out. Anyway.
Kayla talked about it. She said we could review what we do with explosion plot.
That reminds me of Irishman.
Yeah, like I can't. I've seen this. It's like 7 hours long.
It's 3.5
I'm afraid of
hours.
it.
It's so good.
What?
I've heard it's really good. But
Irishman is what Jimmy Hoffa.
Oh, I've heard of it.
It's crazy good.
I'll have to watch like an hour a night or something.
Jenny has it and it's like,
Alright, sorry. You seem to have gotten off track. I think it might be my fault. So let's get back. Okay. So what's the probability of rain and blue? 0.24. What's the probability of blue? 0.6. If you divide those, you get 0.4. So the probability of rain was what? 0.4. The probability of rain given a blue shirt was what? 0.4. Isn't that exactly what's supposed to happen if things are independent?
Yep.
So when I gave you the extra information, it didn't matter. That's what independent means. It should work backwards too. If they're independent, it should work both ways. So find the probability of a blue shirt given that it rains today. So that would be the probability of blue and rain divided by the probability of rain. So the thing you know goes to the bottom. So what's the probability of blue and rain? Still 0.24. What's the probability of rain? 0.4. You divide those, what do you get? 0.6. What was the probability of blue beforehand? 0.6. So when I gave you this extra information, did it change probability? No. That's independent. If I tell you the first one the point is heads, does that change the probability that the second one is heads? No. That's independent. E and R are independent. Extra info didn't change the probability. Or you could say like P of B given R equals P of B. This would be like the mathy stats way to write it. The rest of this is kind of like, I don't know, some of this has to do with what we just did, some of it doesn't. It's more like a review. I want you to try this. Some of it has to do with what we just did, some of it does not. Try the rest, we'll go through it. Aren't there numbers? Your answer should be a number. You guys want more time on these or not? Yeah, okay, that's fine. What?
What's the date today?
16. Right.
It's always Mr. Griffin, so.
How do you have a given, but then have one side of the given be less? On it says A given B is 0.5. Just put probability of B is 0.5.
That means the one on top has to be even smaller than 1.3. So P of B is the 0.3 is like the size of the circle.
Yeah.
And the given is like the both divided by the circle comes out to 0.5. So it's 0.15 because that's half. I'll go through it.
Well, it's like kind of trying to like a Venn diagram to like get a visual.
The diagrams are like that's where the diagram breaks down. You kind of like, Alright, so let's talk through these. So 7. If two events A and B are mutually exclusive, what's the probability of A given B? So think of two things that are mutually exclusive. Like you're in AP Stats this hour, you're in AP Chem this hour. Or any two things you want. If I tell you one of them is true, what's the probability of the other? 0. So if I'm asking what's the probability of A given B, but they can't happen at the same time, if I know B, then A must be 0. So what you're saying, like likely, unlikely, like that's the only number that makes sense. If two events A and B are mutually exclusive, so again, think of two things that can't happen together, like AP Stats this hour, AP Chem this hour. What's the probability of both? 0. Like you can't be in Stats and Chem at the same time, right? Does that make sense? Okay, A and B are independent. What's the probability of A and B? If two things are independent, how do you find the probabilities? Multiply them together, that's like those slots. So you would say 0.5 times 0.4, which would be 0.2. What's the probability of A given B? Well, if they're independent, what effect does B have on anything? Nothing. If they're independent, B doesn't matter. The probability of A given B is the exact same as the probability of A general. And that would be 0.5. Questions on those 4, I guess? 3. This is one where you might start to make a diagram, but it'll break down. You'll be like, okay, wait, I don't have all of this stuff, so you kind of get stuck using that formula that we learned today. So if I write out the formula, I know the probability of A given B is 0.5. I don't know A and B, so I'll call that X. And then the probability of B is 0.3. So you get this algebra formula, you know 2 out of the 3 things. In this case, I would probably multiply both sides by 0.3. Those cancel. You would get 0.15. How many had 0.15? Questions on it? 11 is real similar, so if you go to do a diagram, you're gonna get stuck. If you get stuck doing the diagram, use the formula. How many of you are using, like, if you don't get stuck? How many prefer the diagram over the formula? So, like, if I just give you, if I said just do this, how many would use the formula? How many would use the diagram? So it's kind of, and this is one where if you were someone that used the diagram, you're going to get stuck. And then you're like, oh crap, I have to use it. So the probability of A given B equals the probability of both divided by the probability of what we know. So we get, in this case, 0.8 equals 0.7 divided by probability of B, which we can call X. And then there's that like exchange trick. So I actually do 0.7 divided by 0.8, which is 0.875. Weigh it up. Yeah, that's tough. Questions on these at all? Alright, so here's the plan for, I just gave you one friend. We're going to go through a few more tomorrow. Probably 2 of those will be on your exam test thingy. Maybe the same numbers, maybe slightly changed. We'll have time to go through probably 3, 4, 5 of them. And then you'll see those again, a couple of them on your test. So do this one now, and or for homework, whatever. We'll go through it first thing tomorrow. And then we'll move on to the other ones. Wednesday, I'll give you practice multiple choice. So like tomorrow's kind of like practice Frappy, Wednesday's practice multiple choice. Thursday is the real deal.
Just in the show.
Oh yeah, so there's like a 46% chance that 36 will show up. 30, you good?
It's like an 8% chance that there's right?
Yes. I think airlines do take that chance. Because it like maximizes their profit.
I was just thinking, I'd be so mad.
Yeah,
if
no,
I
also
showed up,
stretch
bought a
people
plane
over.
ticket,
That 8%.
and be like,
Right.
oh wait, we don't have room for you on this plane.
So then that's when, have you ever been to the airport and they're like, we'll offer people $1,000 to take the next flight out. So I did that once. I didn't do it, but I heard that once. I was in Jamaica. They were like, we'll give you $2,000 if you can wait till tomorrow. We'll pay for your hotel. But I didn't get back, so they come. Like 10 people ran up to the counter.
They've done that.
Most people will have to go.
Right.
I was going to Colorado and there was a flight attendant strike on our plane. So we could Los Angeles. So like none of the flight attendants would get on the plane.
Really? So what'd you do? What happened?
So we were waiting.